Welcome back to Computer Science 4300. Today we are talking about assignment 4. So let's just jump right into it, shall we? So here is assignment 4. I'm going to give the demo first, then we're going to go through the text file, then we're going to go through the suggested way of doing the assignment in what order through the text file, and as we go through that, we'll go through the code and explain what you need to do. So here's the assignment. It is definitely not Zelda. So you can hear immediately that we have sound in this game, right? At least I hope that's coming through on the video. So we've got the menu screen here, which is very similar to assignment 3. But now we have Zelda instead of Mega Man and Mario. So as you can see here, we've got controls that are very similar to the original Legend of Zelda game. So I can move up, down, left, and right with the WASD keys. I can attack with a sword. It plays a little animation and a little sword shows up. And I've got enemies walking around now. So we've got NPCs in our game that have hit points. So if I attack this NPC, you can see that I'm dealing damage to the NPC and that NPC then gets destroyed. You can see over here that I have this NPC who's following a patrol path, actually going in various directions. I've got some tiles, some of them that I can walk into, some of them that I can't. If I, this Tech Knight character here, if I move up, all right, I'm going to mute the sound just for a bit. All right, so I'll mute the sound. You know there's sound, so I can just speak freely without the sound being there. If I move up, this NPC can now see me, so it will chase me. Oh, I can also collect hearts. If I take damage from an NPC, I'm going to have some invincibility frames where I can't be damaged again until like a half second later or 1 second later. And if let me restart this actually. I didn't want him to come out and chase me that hard. So if I get hit by an enemy, I just want you to see that I can actually, this NPC is going to hit me. Why is he chasing me? I went down too far. And then I'll turn transparent, and while I'm transparent, I'm invulnerable to damage, okay? So that's some invincibility frames. We'll be implementing that this game. Also, I'm going to have this heart here. If I walk into the heart, I regenerate all my life, and then I can be hit again, right? So that's the type of thing that we're going to be implementing. If I walk up here, I go into a different room, all right? So we've got a different camera view this time where I'm looking at this section of the level, and then I walk up to the top and I go to this part of the level. And there's some NPCs here who will chase me if I'm not careful. Then I can go over to the right, and there's some more NPCs here. Some of them follow me, some of them don't. If I go to the left, I've got a situation where this enemy wants to kill me. It's going to follow me. I'll talk about that more in a second. And if I come down here in the level, I've got this area, and I can't walk through these trees. However, if I look around, there might be a secret here. Oh, I can walk through that tree. Okay, and then the last thing is when I walk into this black portal, it's going to teleport me to one of the other random black tiles on the level. So here, it's porting me down here. So whenever I walk into one of these, it's porting me to a random one of those. Okay. One other thing is, how do these NPCs actually work? Well, let me restart so I can show you. So if I press the F key, is it F, G? I don't even remember. C, okay. So here's the C key, which draws all the bounding boxes. Now, if I press the RT key, it will toggle off the textures. So now I've got some differently colored stuff here. So I'll explain what this means. If a square is colored in black, it means it blocks movement and it blocks vision. So in this assignment, like in the previous assignment, assignment 3, that we had tiles and decks, right? So the decorations were sort of hard-coded to not have bounding boxes, and the tiles were hard-coded to have bounding boxes. What we've done in assignment 4, we've kind of parameterized that. So now any entity in the game can either be it'll block movement, or it will block vision, or it will block both, or it will block neither. So in the config file, which we'll talk about in a little while, you'll see that, for example, these tiles here, they block vision and movement. And what I've done is I've just drawn that in black in this case. So if you can see here, this black tile, I've got a line going from my player character to every follow NPC in the game. And the follow NPCs will follow toward me if they can see me. So you can see here, if this line from me to this character is unbroken, then it will continue to follow me. But if it's broken by a vision blocking tile, then that NPC will move back to its spawn location. Okay, so that's how that works. So let me just quickly kill this one. The white boxes neither block vision nor do they block movement. Okay, over here are some blue tiles. Blue tiles block movement, but they don't block vision. So you can see this NPC here, it can't move through this tile, but it can see me. Oh my, I've got people coming to kill me all over the place. So this one can see me, but it can't move because the water tiles are in the way. So I've, just like a real lake in real life, a lake wouldn't block its vision of me, but it would block its movement toward me. And there's another tile down here, which I will show. And if I look down here, this is a red tile. So a red tile blocks vision, but it does not block movement, okay? So this is sort of how we made this like secret entrance here, is that we said these two tiles here, they don't block movement, so your player will not collide with them, okay? So some other little nitty-gritty details. Actually, let's go over the README file, and I'll come back to the assignment when I need to explain something further. But that's the game that we're making, basically. Oh, the last thing I want to show is that there are these patrolling NPCs, and the patrolling NPCs, you give them a list of points, and they will go from one to the other around in a cycle. I want to show you one more thing, which is a little interesting use case. I need to reset for that, though. Let me kill this one. Over here, we can actually see the patrol points of all of these NPCs. And unlike the other NPCs, I've actually made these NPCs block vision. So when they move up and down, if this line to this NPC is obstructed by one of these NPCs, then it will go back to its home, right? Because these NPCs, I've told them, you can see its outline in red, that they actually block vision, but they don't block movement. So this poor guy over here is a follow behavior NPC, and he's trying to get toward me, but every time one of these blocks them off, he has to go back home. So it's like interesting mechanics that you can implement with this sort of system. All right, so let's go through the README file. Okie doke. I'll bring up a black background so that it's not too distracting, and let's go over this. Alrighty. So the submission, this is the same thing as every other assignment. You're submitting the source folder. However, some people have been really asking me if they can include additional assets for bonus features, and I've been saying yes. So if you do want to include other assets, put a bin folder in with your source folder, and all the assets that you added, put inside that bin folder. Don't just copy the bin folder that I gave you, because it has a bunch of sounds, like several megabytes worth of assets and stuff. So don't include all the old stuff that I gave you in the bin folder. Just put the new stuff that you're giving me in that bin folder, okay? If you choose to include it for bonus marks. Alrighty, so here's the program specification. In this assignment, you will be writing the game that was presented in class, the definitely not Zelda for legal purposes game. Okay? Assets. So entities in the game will be rendered using various textures and animations, which we will be calling assets, along with some fonts. So this is exactly the same as assignment 3. Okay, all the asset stuff is exactly the same. However, we will have sounds now as well. However, that's done for you, so you don't need to worry about the sounds too much. Assets are loaded once at the beginning of the program and stored in the assets class, which is stored by the game engine class. All the assets are defined in assets.txt with the syntax defined below. So the asset syntax, if I can quickly bring this up, it is pretty identical to assignment 3. So I won't go over all of that. However, just know that now we've added sounds, okay? So if you want to play sounds in the game, I have included some sounds in the bin folder. So for example, we have the title screen music that plays when you launch the game. You have the music level that the level music that plays when you're inside the game. You have some sounds when Link takes damage, when he dies, when an enemy is hit, when you slash the sword or get an item, etc. So you can play sounds in the game with this string here. That's how you get access to those sounds. All right. So that's the asset file. I don't need to go over that in detail because I covered it in assignment 3. But the player is very different in this one. So the player, all right. The player entity in the game is represented by not Link, again, for legal purposes, which has several different animations. Run down, run up, run right, stand down, stand up, stand right, attack up, attack down, and attack right. You must determine which direction and state the player is currently in and assign the correct animation. So, the player is assigned the following animations in the direction facing. Please note that left will be accomplished by mirroring right. So if you just set the X scale of the player's transform component to -1, everything will be flipped in the X direction. So that was a little thing you could do in assignment 3 as well. So stand dir, so dir just meaning the direction, so up, down, or right. So stand is when no input or opposite inputs are given to the player. Opposite meaning if you hold down left and right, nothing should be happening, okay? Run dir is when the move input is given to the player in a given direction. And attack dir is when the player's sword is currently visible from an attack. And you have left, right, up and down, W, A, S, and D, and attack is the space key. So the controls are the same from assignment 1. So what does that all mean? So if you look, when I'm playing the game, if I'm doing nothing, then the player is just standing. If I move to the right or to the left, then there's an animation that's playing with my feet just going like this, right? So that's the walking, or the, what did I call it? The run animation. So that's when Link is running. Whenever I stop running in a particular direction, Link stays in that direction and the stand animation is played. Now, if you look in the bin folder, so images, Legend of Zelda, there's like attack. Oh, you can't see this. Give me a sec. So there's attack down, attack right, attack up. There's no attack left. Okay? So I've given up, right, and down for all the animations. But the reason I didn't give a left animation, if I can maximize this again, is because left is just a mirror of right. Okay? So if you take the X scale of the animation and you change it to -1, then it'll just be facing left. All right, so that's how you change that. However, you can't change the Y scale for up to make it down because that would just, turn the back of Link upside down. It wouldn't actually be showing the front of Link. So there's an up animation that shows the back, there's a down animation that shows the front, there's a right animation, and then you just flip the right animation to go to the left. And then when you're attacking for half a second or something, I think I have a specification on this, you play this sort of like your feet spread apart for a second when you attack. So that's the attack animation, and also the shield disappears. Okay? So that's what all of that meant. Okay, so the player can move up, down, left, and right at any time during the game. The player can only move either horizontally or vertically at any given time. So what that means is, if I launch the game again, all right. So what that means is, if I hold left, I'm moving left. If I hold down, I'm moving down. But if I hold down and left, I'm only moving left. Okay. Now, you could choose down. I've just chosen to prefer the horizontal directions. But if you hold up and left or any diagonal direction, you can't move in diagonals in this game. You can only move in one direction at a time. Someone in the chat just mentioned that right is technically not the mirror of left, because then the arm that, or the hand that he's attacking with, is actually mirrored. We're going to ignore that for now. Good point, but we'll just ignore that and use the mirror. Okay, so Link is ambidextrous, and whenever he turns around, he switches the stuff. How about that? All right. If opposite players are held, the player will be given the standing animation. The player can only attack once its current attack animation has finished. All right, what does that mean? So, if I'm spamming this, it's still like the attack duration is still the same, okay? So for that third of a second or whatever it may be, you can't give another attack command during that attack frame, okay? And also, if you look really closely, Link, when you attack, the sword is in front of Link, even if you change directions for that period of time. So I know that this is a little bit hard to see, but what I'm going to do is I'm going to attack and immediately face downwards. Look. You see that? So the sword, however long the sword is out for, it will remain in front of Link. So you have to update the sword animation like every frame if the sword is currently out. So that's a little thing that might be a little bit tricky. But it does make the gameplay cool, because then you can, like, in one attack, you can attack in front and then turn around and hit something behind you, right? Just watch. See that? Like, it adds a little bit of skill to the game. It's pretty cool. All right. Next thing. The player collides with tile entities in the level. See the level syntax. Whose bounding blocks, that's a hard sentence to say. The player collides with tile entities whose bounding box blocks movement and cannot move through them. Okay? So again, let's just run the game. So for example, these tiles here I can't move through, right? So anything that blocks movement, I cannot move through, like this. Okay, that's what that means. The player will be given a bounding box of a size specified in the level file. We'll get to that once we get to the level file. The player will be given a C health component with a maximum health that is specified in the level file. When the player's current health is less than or equal to 0, the player respawns and the Link die sound should play. If the player has a C invincibility component, it takes no damage from enemies and its sprite is made transparent. The duration of the component is reduced each frame, and when the duration reaches 0, the component is removed, making it vulnerable to attacks again. So when the player collides with an enemy while not invincible, so the default state of Link is being not invincible, right? Whenever you collide with an enemy, the player's current health is reduced by the enemy's damage component. We'll talk about that in a sec. The Link hit sound should play, and the player is given a C invincibility component which lasts for 30 frames. So what happens is, whenever you're hit, you... one second. Got to ban a troll from the chat. There we go. Whenever you're hit, the player is given an invincibility component, and it lasts for 30 frames. Every frame of the game, you're going to look through all the entities in the level, and if they have an invincibility component, you're going to subtract 1 frame from it. And whenever you go to do collisions, you're going to say, okay, if the player collides with an enemy, it's only going to take damage if it's not currently invincible. Okay? So that's how these invincibility frames are going to work in our engine. And as soon as the invincibility duration reaches 0, you remove the invincibility component, and then you can take damage again. So it's a really simple method of adding invincibility as a status effect. And remember that in your project, you need to have multiple different status effects. So you could think of, just like invincibility here, maybe you could have like double speed component or something like that, or some other status component that has a limited duration. All right, other entities. Each tile and NPC in the game specifies 2 Boolean values of whether it blocks movement and whether it blocks vision. If a tile blocks movement, the player collides with it and cannot pass through it. If an entity blocks vision, then it does not affect enemy line of sight, and see the specification below. So we haven't gotten into that syntax yet, but I'll get into that soon. Bounding box has the bounding box component, C bounding box, has 2 new booleans to reflect these changes. So if I go over into my components here, so here's our new invincibility component. We also have a damage component. And if I can find the bounding box, so before, our bounding box component in assignment 3 only had size and half size, but now it has 2 extra booleans of whether or not it can block movement and whether or not it can block vision. Okay? All right. Whenever the player steps onto a tile with the black animation, so the animation called black in the assets file is literally just a black PNG, and that's like the door or whatever that we have. They are teleported to a random black tile on the map. So whenever you see that the player collides with the black tile, you just loop over all the tiles in the level, and if there's another one with the black animation, then you teleport to one of those randomly. And I already showed that behavior. Okay, attacking. Whenever the player attacks, a sword appears for 10 frames and then disappears. It appears approximately 1 tile away from the player in the direction that they are facing. The sword should be given a bounding box equal to the sword's animation size. When the sword collides with an enemy, it deals its damage component worth of damage to the health of the enemy that it collides with. The sword should only do damage for 1 frame, and then its damage component should be removed so that it does not deal damage for every frame that it overlaps. So what does this actually mean? Because this is a little bit complicated. I'll show you. All right, so let me try and take a screenshot here. How am I going to do this? Jeez, this is actually kind of hard. Let me see if I got that screenshot correct. All right, perfect, I did. So I'll edit this. Here we go. Crop. All right. So here, let me make this a little bit bigger. Here I've got a situation where, so the sword is out for 10 frames, right? So here's Link. Let's just draw some fake bounding boxes here. So let's say this is Link. This is Link's bounding box. Here's the bounding box of the enemy. And here is the bounding box of the sword. Okay? So the bounding box of the sword is overlapping the bounding box of the enemy. So what happens is, if all you do is detect a collision between the sword and the enemy, and immediately just remove health from the enemy, then for the entire 10 frame duration of the sword, you're going to be dealing damage to the enemy each frame. So this would actually deal damage to this enemy 10 times, right? Unless we somehow detect that damage has already been done, so don't let it deal damage again, right? So what we do is, whenever we spawn the sword, it has a damage component attached to it. And whenever the sword collides with an enemy, it's going to deal that damage, and then you're going to remove the damage component from the sword. So that on the next frame, you can see, oh, there's no damage component on the sword anymore, so we don't have to do any collision checking anymore, right? So I know before I said that I could attack in one direction and then flick to another enemy. That's actually not, well, it's still true. However, it won't deal damage to the second enemy because its damage component was removed, okay? So just realize that that's what's happening here. And the reason for that is because we haven't given the enemy any invincibility frames. So you have to do either one or the other. You have to tell the sword that it can't do damage anymore, or you have to tell the enemy that it can't take damage anymore. And what I wanted to do for this assignment is just show you how you could do this mechanic, right? By taking away a component to affect the behavior of something. So that's what you're going to do there. You're going to take away the damage component from the sword as soon as it's hit an enemy. Alrighty. The next thing. When the sword is swung, the slash sound should play. That's pretty easy. When the sword collides with an enemy, the enemy hit sound should play. When an enemy's health is reduced to 0, it should be destroyed. When an enemy is destroyed, the enemy die sound should play. Someone asked, so for the 10 frames the sword is hitting the mob can still move forward. Yeah, I haven't put any restrictions on what happens to the enemy. The enemy doesn't get knocked back, the enemy doesn't get frozen or whatever like that. And I know that that's not, it's not how like the original Zelda worked, but it's how our assignment is going to work. I didn't want to put too many little nitty-gritty things on you like that. Can the sword be held out while walking, or do we not have to worry about that? Well, the answer to that is going to be whatever the solution does. So let's see here. Yeah, okay, so I can move and slash. So the mechanics are not the same as the original Legend of Zelda, okay? So you can move while the sword is out. That's fine. Okay, you can move while the sword is out. Good questions. Let's go back to the thinger. Alrighty, to the thinger, the README file. So NPC entities. So there are now NPC entities in the game. Each NPC entity will be given an AI behavior in the level file, which is either follow or patrol. So this is very, very, very basic AI, right? If you want to know more about game AI, I have an entire course on game AI, which is offered in January, okay? Which will also be on YouTube and streamed on Twitch. So a follow behavior means the following. It will follow the player when the player is in direct line of sight, or head back to its original position when not in line of sight. When an entity is at its home position, it should not oscillate. And what that means is that when you've gotten back to your home, something that can happen is that, let's say, like, the player is right here. So let's see here. I'll get this. All right. So let's say I've got an entity and it's moving back to its home position, which is going to be this dot over here. Okay, so this dot over here is its home position. So let me select this again. So this enemy, when it's moving back to its home position, it's going to get there, but what's happening is on each frame, it's going to be moving some amount of distance. What I do not want to happen is that on some frame, it's on one side of the home. On the other frame, it's on the other side of the home. And so what happens is it goes like this, back and forth on the home position. What I want you to do is detect when the enemy is close enough to the home position, and then just say, okay, it's home now. So it doesn't oscillate like that. A patrol NPC means it will move toward a series of patrol positions, looping back around to the start when the final one is reached. An NPC has reached its patrol position if it is within a distance of 5 pixels from it. So let me explain how this works. And I'm going to get a screenshot. Well, first let's look at the behavior. So, is it G, C? Okay. So this NPC down here is currently on a loop. It has 5 patrol points. Those patrol points are going to be specified in the level file. Okay, and we'll get to how they're specified. But you're going to be given these points, and it could be any number of points, right? So for example, this patroller down here just has 2 points. So it goes from point 1 to point 2, back and forth, back and forth, back and forth. This one has been given 4 points. So it's going to start at the first one, go to the next 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 one, and then back to the start. Okay, so if I can take a screenshot here of this. There we go. I may have frozen while that screenshot was being taken. So I'm going to crop this, resize it. Here we go. Now I can get rid of this. All right. So this is what this means. Let's say that this is patrol point. I've given you some patrol points, and you're going to store those in a vector. Okay. So let me actually show you the component for this. So the patrol component is going to contain a vector of vectors, and those are the positions. It's going to take a current position, and it's going to take a speed. So what do those mean? All right, let's go back to the diagram here. So here I've got my vec2 of 4 different positions. So let's say this is V0, this is V1, this is V2, and this is V3, right? So I've got a vector of 4 positions, and I've also got a current position. So let's say that my current is equal to 0, as it is right now. So what that means is, wherever the NPC is currently, this current is the index of the position in the vector that I want to currently head to. Okay, so my current position is 0. So that means no matter where I am on the map, I'm walking with a given speed straight for position 0. So let's simulate that here. So here's the NPC. I'm gonna, 1 second here. I don't want this to be that. So if I think I can do this, where I choose this color on this one, and then it'll keep the color when I move things. No, okay, that doesn't work. So this player is currently moving toward position 0, and then they get within a certain distance of position 0, and what I have now is that I have arrived at position 0, okay? So once I've arrived at position 0, then my current is going to get a +1. So now it's position 1. So this one is now going to say, okay, where's position 1? Well, I'll walk toward position 1. And then I get to position 1, current changes to 2. So now I'm walking toward position 2. It changes to 3. I walk toward position 3. When I get to position 3, okay, there's no more places, but I want you to walk in a loop. So if you're at the end and you've gotten there, you go back to the start. Okay, so that's how all of that works. That's how the patrol behavior works. The follow behavior is a little bit different. So let me get a screenshot of the follow behavior for you. All right, so let me turn on the drawing, and let me go up here. I think this is going to be a bit easier. Here we go. All right, so I got a screenshot. I'm going to come back. Oops, that's the wrong place. Here's the screenshot. I'm going to crop that. Perfect. Okay, so I'm going to make this a little bit bigger. So I'll just take this, I'll crop it and make it 200%. There we go. So these NPCs have been given a follow behavior. And if we look over here at the components, the follow player behavior is it's got two things. It's got a speed and it's got a home position. So the home position is where the NPC is going to walk to if it currently cannot see the player. So the rule is if the line between the center of the NPC, so let me just show you that. If the line between the center of the NPC and the center of the player is unbroken by a vision blocking tile, then it is currently walking toward the player. However, if vision is currently being blocked, like for example, these guys up here, they have the follow behavior as well. These dots right here, that's the home location of these things. So they've been given the home location. If they can't see the player, then they're going to slowly walk back to their home location. So let's just see that in action again, so you can understand that. Let me maximize this. So if I go here, this guy currently can't see me. I'm going to move up a little bit so this line becomes... What's going on here? Oh, there's another version of this running? Oops. Okay, so sorry, you couldn't see that. All right, so this one, when this line is broken by this vision blocking tile, okay, then it's going back to its home position. But when it's not broken, it's coming toward me. See that? So I'm going to break its vision again with this one over here, and then it's going to walk back to its starting position, which is this down here. Similarly, if I come up here, this guy right here wants to come at me. So as soon as this line is not broken, he'll come after me. As soon as it's broken, he'll go back to the starting position. Okay? Perfect. So let's go back to the README file. That is how that works. So that's how you're going to set up a component, which is sort of the AI component of the NPC. And that's the patrolling behavior and the following behavior. Let's talk about tiles now. Tiles are entities that define the level geometry in the player, and actually, these are all the same as assignment 3. So tiles can be given any animation that's defined in the asset file. Tiles will be given a bounding box equal to the size of the animation, and the current animation displayed for a tile can be retrieved with this. So this is the same as assignment 3. However, if a tile is given the heart animation, any NPC or the player that collides with it should have its health filled to maximum and the tile is destroyed. So let me just show you one more thing, which may have not been obvious. So if I deal damage to this guy here, and then he walks through the heart, so either me or an NPC will be affected by the heart, and then the heart tile is removed. Okay? All right, so that's how that works. Drawing. The game, so all the rendering is done for you, okay? You just have to do one thing based on the camera. All right. So, I was just reading some questions in the chat. Some of them are not relevant. Someone said... All right, so they're not like really relevant to answer right now. So drawing. I've done all the rendering for you. Okay, so that the rendering is done. The window is given a fixed size of 1280 by 768 pixels. And that is going to be 20 times 12 tiles. So tiles on the game are just like assignment 3. They're like 32 by 32 fixed size tiles. Rendering of entities is provided for you, as well as a debug rendering mode that can be toggled with the C key, and the T key toggling texture rendering. So this debug mode, as I said before, if I press C, I can see all of the different tiles, right? I can see the lines. If I press T, I can turn off the animations. If I press both, then I'm not actually drawing anything. Here's what you are required to do. You are required to change the camera position, so the window.view of the game, to alternate between two camera modes based on a variable that I have. So you don't have to do any of the rendering. The rendering is already done for you, but what you do have to do is change the view of the window to be one of two different camera systems. So the different camera systems are as follows. The first one is the room view. So the room view, as you can see, the camera is not moving as I'm walking around, but it does change when I walk off the screen in that direction. So I've gone from one room to another room. Now, these rooms are just virtual. They're just the camera, okay? There's no like separate level file for each room. They're all the one level. However, when I walk around, I'm changing the camera based on where I am, okay? If I hit the Y key, I switch to the other camera mode, which is follow camera mode, where Link is in the center. And you can see what a dramatically different gameplay this produces. It's actually like almost makes me motion sick playing Zelda with this camera mode. So you have to implement those two camera modes. But that's it. You don't have to do any of the rendering. So this is what it looks like with the follow camera, and this is what it looks like with the room camera. Obviously, for Zelda, I think we can all agree that the room camera is the best choice. Okie doke. I'll get to what room... Okay, here's what rooms mean. Each level is split up into individual rooms given an XY coordinate. Room XY is defined by the rectangle X times width, Y times height, width, height, where W and H are the window width and window height, respectively. When not Link moves to a new room, the camera should center to that room. Okay, what in the hell does that mean? Well, let me see if I can string together some screenshots to try and explain this a little bit better. So let me take a screenshot of this. I'll go back over here and I'll paste this here like this. And what I'm going to do is, okay, let's take this. Now we'll delete it, resize. Sorry, I've got this up and running. I'm here in Paint trying to make something truly excellent. All right, so here is where we start the game with this level. So the level, in fact, is everything, okay? So that's the starting room. If I bring this up and I go up here, here's another room. So I'm going to paste this in here and just make it a bit smaller so I can fit it. Oh, dear. Not small enough. All right, let me make this a little bit smaller. We're doing it live, folks. This is what teaching is sometimes, but it's fine. All right, here's the other one. I'll make this a little bit smaller. All right, here we go. Now I'm going to drag this one down, this one down. Now it's not going to be perfect, but we're going to deal with it. Here's another one. This is more explanation than I gave any other offering of this course, so this is another room. I'm going to make that about the same size. Now these aren't perfect, but we're getting there. All right, here we go. All right, so you get the idea. There's only 5 main rooms here, so I might as well just get the last one. Here's the last room. Paste it in here. Okay. So the actual level extends to infinity in every direction. And actually, just for completeness, I want to show that like these are actual rooms up here too. I just don't have anything in them right now. So I'll get a screenshot of that. I'll take this and I'll put it up here. All right, cool. So this world extends to infinity in all directions, okay? But I'm calling each of these a room, and each of these is has dimensions 20 tiles. Oh, geez, that's a terrible color. So the width is 20 tiles, and the height is 12 tiles. Okay, so that's the dimensions of a room. A room is also given a room coordinate. So the room coordinate for the main room is 0, 0. Okay, and the room coordinate for this room up here, this is room 0 in the X direction, -1 in the Y direction, because it's one room above, and we go upwards above the initial room. This is room 01. This is room 10. This is room, this would be room -10. And this would be room -1, -1, and so on and so forth, right? So the way that you figure out the coordinates of the room is by taking the X and the Y and multiplying by the number of tiles, and then multiplying that by the tile size. So the tile size in the game is 32 pixels by 32 pixels. So let's just do one small example here. If I'm trying to figure out the pixel XY coordinate of room 10, how would I do that? Well, the pixel X is going to be equal to 1, which is the X room number, times 20, which is the number of tiles wide a room is, right? Times 32 pixels, right? Okay. PY is going to be equal to Y, which is 0, times 20 times 32 pixels. All right? So room 10 down here, this pixel right here, the top left pixel of this room right here is going to be located at world geometry pixel 20 times 30 in the X direction and 0 in the Y direction. Okay? And if you look at this intuitively, yeah, that seems about right. Okay? And you just change X and Y for each other room. So what you have to do is you have to take Link's world position. Okay? So you take Link's world position and you say, okay, well, Link is currently at, let's just say like Link XY is like negative 400 in the X direction and 300 in the Y direction. Okay, so negative, if this is 0, 0 right here, and that's a bit small, so let me get a big old green dot here. If this right here in the middle, if that's the 0, 0 coordinate, then we're going to go negative 400 over here and then positive 300 down here. So this is where Link would be in the world if they were at negative 400, 300. So what you have to do is you have to figure out which room Link would be in at that position, then figure out the top left corner of the room, the width and the height of the room, and set the camera view to that rectangle. Okay? So if it was negative 400, 300, you somehow determine, oh, Link is in room negative 10. I determine the pixel coordinates of the top left corner using this formula up here. And I have the width and the height. The width is just 20 times 32, and the height is, oh geez, the Y coordinate is supposed to be 12 right here, not 20. Apologies, this is 12, this is 12, this is 12. So yeah, that's 12 tiles. So then you would say, hey, window.setView these coordinates. So I don't want to do any more because that's a huge step forward in how you do that, and you'll probably be very easily capable of doing that after getting that hint. Okay, so that's how the world is set up, and that's how it's split into rooms. And if you have that follow camera active, then all you have to do is put Link in the center of the screen. Okay, and there's literally a center of the screen variable. Or sorry, when you can set the center, that's a function on the window. All right. Oh no, have I been saying, jeez. So 20 times, yep, you're right. It's 64, so tiles are 64. I don't know why I keep saying 32. So hopefully you've made it to this far and you haven't just turned off the lecture and gone immediately coding. But all of these places I have 32, that's actually 64, and this place right here is 12. So that's one of the issues with doing it live. Sometimes you can mess up a little bit, but it is a grid of 64 by 64 pixel tiles. Okay. Alrighty. Someone asked, is A4 available? I think it's available. You can go test your link if you want to. I put it up there, so unless I made a mistake, you can go get it right now. Okay. Back to the README file. We've gone over that. Here are the miscellaneous. The P key should pause the game. C toggles wireframe and debugging. T toggles rendering. Y should go back and forth between follow or room. And escape should go back to the main menu or quit if you're on the main menu. Perfect. All right. There will be two configuration files in the assignment, the asset config file and the level configuration file. So again, the asset file is identical to assignment 3, and you don't need to worry about that because it's all read in for you, so don't worry about the asset file. However, the level file is different, okay? So the level specification file, let's open the level. Alrighty. So the level specification file is a little bit different, and we'll go over that right now. So here I will move this so I can have both on the same screen. Perfect. So the level specification file, first we have the player specification, and the player is going to be way down on the bottom. Okay, so let me make this a little bit wider. So the player has the following variables: x, y, bx, by, sh. So x and y are the spawning position in pixel coordinates. Bx and by are the bounding box size in pixel coordinates. S is the speed of the player, meaning the amount of distance they should travel every frame when they're walking around. And H is the maximum health of the player. So if I change maximum health to 13 and then relaunch the game. Oh, never mind. The solution code is not correct. That should be the maximum health of the player, but it is not. Okay? It's not in the solution, so I apologize. Do what I say, not what I do. The solution is not 100% correct, unfortunately. All right, so that's the specification for the player. The tile specification has gotten a little bit more complicated, but not too complicated. So the tile is specified as follows. So the first thing is going to be, well, first is going to be tile, and then we're going to have name. So we have tile and name. Let me move this down a little bit. So name here is just rock bottom left. That's one of the animations that we have. Next is the room coordinate. So this tile should be placed in room 00. And then within that room, it should be placed at tile 13, 0. Okay, so if we go back here, so that tile, and let me just zoom in here. Actually, let me, I'll show you this example because it's on the starting screen. So here we go. I'll paste it here and I'll crop. Perfect. So this is room 00. All right, the room that we start out with is room 00. So if this should be placed in room 00 at tile 13, 0, then 13 is in the X direction, 0 is in the Y direction. So this is the tile right here. That is that first tile. And you can see how it's the bottom left corner of a bunch of rocks, right? And if we look at the level file, then the rock bottom middle, there are 5 of those, 1, 2, 3, 4, 5, that go right here. So what you have to do is you have to take the 64 pixels, right, in the X and the Y direction and just multiply those by the X and the Y, and that's where they should go in the level. So you take the X and Y coordinate of the top left of the room, which you already know how to calculate from my previous mangled geometry, and then you add to that top left coordinate position, which is currently 0, 0, right? You're going to add, so this tile here would be, well, we have 0, 0 for the room coordinate. The X is going to be equal to 13 times 64, okay? Where am I going here? Come on. 13 times 64 in the X, and the Y is going to be equal 0 times 64. However, that is going to be the top. Yeah, so that's the position of that tile. My apologies. So that should just work, right? And that's how you do it for all the tiles and for the NPCs. So let's go back to the explanation. So the next few variables are, so this one here, this was the room coordinate. The next one is the X and Y tile coordinate within the room. And the next two are whether or not it blocks movement. So this is BM. And so it's an integer, 1 if true, 0 if false. So if this is a 1, then that tile blocks movement. And if the next one is a 1, then that tile blocks vision. All right. So that's not that difficult. I just had a kind of roundabout way of saying it. So let's just read through one of these things for completeness. So this is a tile. It has the animation rock bottom middle. It should be placed in room 0, 0 at tile position 16 in the X, 0 in the Y. It should block movement and it should block vision. Versus this tile down here, that is a tile with the animation black, so it's just a black square. It's in room 0, 0. It's at tile 4, 3. It does not block movement and it does not block vision. Okay, so that's the tile specification. And if we look down here somewhere, I'm going to have some bushes down here. All right, so in the game where we had those like secret bushes that you could walk through, here we specify that bush, right? So let's just look at the game again. So here's the game. If we go down to room 01, where we are right now, then here's the specification of all these bushes. So for example, tile bush is in room 01. So this is the room that we're currently in because it's one room down. It's at position 7 in the X direction. So that would be right here, tile 7. Oh, I got someone coming after me. Oh, I'm going to die. All right. And it's at 0, 1, 2, 3, 4 in the X direction. So you can see here that I've specified like 7, 8, 9, 10, 11, 12, 13. So those are these bushes here. And then I've specified the bottom ones. Okay. Have I? No, I've specified this side going down this side. Then I've specified this side going down this side. But this one here, it has a 0 because it does not block movement, right? So if I turn off texture drawing and turn on debug drawing, then this one here has a red outline because it doesn't block movement and I can walk through here. Okay, because we did not give it the block movement Boolean right here. All right, so that's how you specify tiles, just those few variables. Not too bad. The NPC specification is going to get a little bit more complicated, but it's not so bad. You know how to read from files by now. So let's make this a little bit narrower. And we'll make this a little bit wider. All right, so here we have the NPC specification. So it will start out with NPC, then we'll have the animation name. So this one right here, this is a tektite, all right? So this is NPC tektite, and this is at room 0, -1. So the first two integers are the room X and the room Y, followed again by tile X and tile Y. So this is at X equals 6, Y equal 2. Whether or not it blocks movement or vision, it does not block movement or vision, okay? It's got a maximum health of 2, that's this H. It's got a damage of 1. And then you've got the AI behavior name. So here the AI behavior name is follow. And depending on whether or not it's follow or it's patrol, the next parameters will be different. So if it's follow, it only has one other parameter. And that other parameter is the speed at which it should follow the player. Okay? And that's speed S. So that's just a floating point number. So you will calculate the vector that you have to go toward the player. You'll normalize it and then multiply it by s. In this case, it's 3. Okay, so that's the speed that this person should follow you at. And when it's not following you, it goes back to this home position, which was specified right here. And if we look over again at the follow player component, you will store that home position so it knows where to go back to. And you'll also store the speed at which it should move. Okay. Now we're going to go back. If it says patrol, however, it's going to be a little bit more complicated. So let's look right here at how patrol is done. So patrol is going to have first number is a speed. So right here, let me put this a bit up. This tektite is going to refer to the tektite that has 2 patrol positions in the first room. So it's at room 00 at position 39. It doesn't block movement. It doesn't block vision. Okay. The next, it has 8 maximum health. It does 1 damage, and it has the behavior of patrol. The next variable is S, so that's the speed at which it patrols. The next number is N, which is the number of patrol positions that it has. So this one has 2 patrol positions. And then the following N times 2 positions are X, Y, X, Y. So it has 2 patrol positions. So we have 4 points, right? This is the first patrol position. So it's tile X equal 3, tile Y equal 9. And then the next patrol position is tile X equals 7, tile Y equal 9. So this NPC is going to start at this location. And then it's going to move toward the first position and then patrol to this position, then back to this position, then back to this position. Okay? So if we look at that in the game, that is this one down here. Here is X equal 3, Y equal 9, right here, this first patrol point. This is X equals 7, Y equal 9 right here, and it moves at a speed of 2 pixels per frame. And so it just goes back and forth, back and forth. So let's look at this one here now. So this one has 4 patrol positions. So this is where this one is defined. So it's going to have a speed of 2. It's going to have 4 patrol positions. And here we have the first patrol position, the second one, the third one, and the fourth one. And they're defined in tile coordinates for the room that it's in. Okay? So that is the patrol. I'm not going to go through every single example of patrolling for the level file, but this is the level file. And it gives us a bunch of power in how we can specify levels. And you can see how this is now like building into a pretty cool game engine that we can do all this for. All right. So I gave an example here where I just walk through exactly what I just did, but I'll leave that for you to read because I'm not going to read that again. Okay. So the cool thing about this is that you can use all of the collision code from assignment 3 for this assignment. All right. And if you did the collision code correctly in assignment 3, it should still work for assignment 4. So all those collisions are going to be no problem. They should still all work, and you can just copy and paste it from assignment 3. I'm going to have those same physics functions for you to implement. So I recommend approaching this assignment in the following order. First, implement WASD movement for the player such that it moves up, left, down, and right when those keys are pressed. This will allow you to test rectangular collisions as soon as possible without implementing gravity. Oh geez, this is a typo. I copied and pasted this from the other. Damn it. So I copied and pasted that from the other assignment. There is obviously no gravity here. This is an example of a copy and paste mistake. Please do not, there is no gravity, right? There's no gravity. So don't ask me about the gravity. If you ask me about gravity, I'll link me telling you not to ask about the gravity. So next, it says, implement game state play load level. Oh, jeez, I'm bad. This should be scene Zelda load level, Okay, so Scene Zelda load level, which will allow you to load the assets for the level for you to test with the rest of the assignment. So if we go to Scene Zelda, just like assignment 3, okay, you're going to have to register your actions right here. So you're going to have a left, up, down, right attack that you're going to add here. So just again, like you can register action. I want A to be left, for example, right? So I'm not going to go over all this again because I did this for assignment 3, but down here in your do action function, you're going to be like, okay, if action name equals left, then I'm going to set the player's input component, and then I'll read the input component in the movement function. Okay, so we did that for assignment 3. We don't need to talk about that again. That's going to be pretty easy for you. However, here is where the load level should go. So just like assignment 3, you can, you can even copy and paste a lot of that code over here for assignment 4, because if you look at the level file, right, there's a lot of stuff in common. So, the setting up of the file reading, the fin, file reader, the parsing of the token at the beginning of the line, all that kind of stuff can just be copied over. And so here's where you do that. And just like assignment 3, I had the grid to mid pixel function. What I have here is a get position function. And the get position function is where you take in a room XY coordinate and a tile XY coordinate. Okay. And you return the vec2 game world position of the center of the entity for that. All right? Excuse me. So you have to return the center of the entity. So you're going to have to calculate room X and Y times 20 tiles times 64 in X and Y direction, or 12 tiles times 64 in the X and Y direction, plus TX times 64 in the X and TY times 64 in the Y, and then add half of your entity's animation size. Okay, so that's how you do that one. And here, you're going to use that function when you actually spawn, or you create all of your entities. All right? Okie dokie. Let's see what I give you off the very start. Let's see. I can't even remember. It's been a while since I looked at it. So what we do is I give you this, and this is what you're given. You can't move around. We've spawned a temporary player here. So let's see how we've spawned the player. So again, we've asked the entity manager to give us a player. We have given it a transform of 640 by 480, which is the center of the screen down here, a little bit below the center. We've given it the animation of stand down, and we have given it a bounding box of 48 by 48. So if I hit the C key, I have this here. Now, blue was the color of the water. That should mean that it blocks movement, but not vision, right? So if I look here, it blocks vision. Oh yeah, it blocks movement, but it doesn't block vision. So our bounding box constructor takes in a size for the bounding box, as well as does it block movement and does it block vision. And I've given my player a health component. So the health component over here, we can construct it with a maximum health and a current health. So the maximum health is first, the current health is second. And what I've done, just as an example, is I've given the player a maximum of 7 health, right? But a current health of 3. So you can see that 3 of the 7 health are there. And I've done the drawing of those for you. So don't worry about that. Okie doke. So that's what we're going to do first. Next, what do we do? Implement the camera changes described above. Okay, so let's see where we do that. In the Scene Zelda, there is a camera function. Okay, so what we're going to do in the camera system, the Scene Zelda is going to have a follow variable, and that follow variable should be changed. It's already done for us, actually. So if I look up here, Y toggles follow. Okay. Oh, this should be toggle toggle follow camera. So if we hit Y, that does the toggle follow action. Toggle follow changes the M follow variable from true to false or from false to true. So whenever we hit Y, it's going to toggle back and forth between those two cameras. And here I've already given you, okay, here's how we get the view. So this is the current view of the game window, right? So this is mgamewindow.getView. If we're supposed to be following, change this view so it follows the player. Otherwise, it's the room-based camera. So here is where you would calculate the room that Zelda or Link is in, and you would center the camera at that room. Okay, so here's where you do the following stuff. Here's where you do the room-based stuff. And then once you've updated that view to be the correct view, then we just set the game window's view to be that view. Okay, and so use the calculations I did previously in the lecture where I showed you what the different rooms mean, all the calculations, and please use 64 and not 32 to calculate that. So that's what you have to do next. Next, implement spawn sword so that it spawns a sword in the correct position with the correct lifespan. Alrighty. So if we look over at components now, I have included a new, there's this facing thing in the transform. So what does the facing thing in the transform mean? Well, facing is an XY. So if I can, let me resize this a little bit. So here, Link is currently facing downward. Okay? So what is down? Down is 0 in the X and 1 in the Y. So by default, when Link spawns, it's facing 0 in the X and 1 in the Y. Whenever you press the left button, okay, Link is going to now, oh no, that's not this. Link, if you press left, Link is going to be facing left, which is -1 in the X and 0 in the Y. So whenever you detect that the left button has been pushed, make sure you change the facing to that direction. Similarly for right, similarly for up. Then, when you're in the animation system, you're going to set the correct animation either to the right or to the left, up or down, based on whether or not Link is facing in a particular direction. So you can say if link.facing.y is 1, then you should be going up. So you're playing the up animation, okay? So that's how I recommend implementing that. Alrighty. So spawn sword, if I can get back to this, if you are facing down, then the sword should appear right here. If you're facing to the left, the sword should appear right here. If you're facing to the right, the sword should appear right here. And just look, ever so conveniently, facing is 0, 1. If I multiply those by 64, I get 0, 64, which just so happens to be the offset from Link's position where the sword should be spawned. 5 head, right? It's already done. Okay. So what you have to do is implement back in Scene Zelda the spawn sword function. Where are you? Spawn sword. Okay. So in spawn sword, you are given an entity as the input. That is the player, or that's the entity which controls the sword. If you want to give other NPCs swords, you can. That could be a bonus feature. But this is the entity, usually the player, that has the sword. So what you have to do is you have to spawn the sword, which should be given the appropriate lifespan. I think it's 10 frames. It should spawn at the appropriate location based on the player's facing direction. It should be given a damage value of 1, and it should play the splash sound. Now, I haven't told you how to play sounds yet, but it's very simple. I've done it for you. Inside the game engine, I've already have a function, which is GameEngine.playSound. Okay, so really, really easy. All you'd have to do is be like M engine. Let me see how you actually do this. This is a sound name. So M game play sound, and then you would play slash, if that's the correct sound name, okay? And the sound names are all given in the assets file. So whatever this is, if you want to play link hurt, then you would play link hurt right here, okay? So that's how you play the sounds. Really easy. Alrighty. So that's the spawning of the sword. Where am I now? Implement player attacking and sword collision with NPCs and health and damage. I recommend doing that next. So that is in the collision function. So down here, we're going to have, oh, that's my rendering function that I wrote for you. Where's collisions? Collisions. All right. So collisions, you're going to have to implement entity tile collisions. So that meaning like if tiles block movement or not, right? You're going to have to implement enemy player collisions with the appropriate damage calculations. You implement sword to NPC collisions. You implement the black tile collisions and teleporting. You implement entity hurt collisions. So this is the life gaining logic. And you may want to use some helper functions for these, or the function will get really long, right? So don't be afraid to create your own functions if you want to. Alrighty. Implement player animations to correctly animate based on the player's state. So here, you're going to implement in the animation system, implement the player facing direction animation, implement the sword animation based on where the player is facing. So the sword should move if the player changes direction mid-swing. Implement the destruction of entities with non-repeating finished animations. So this you can pretty much copy from assignment 3. And implement the NPC patrol behavior, and then implement NPC follow behavior, but without vision at first. So what you want to do here is just make sure that you have following correct, but don't do the vision calculations yet. I'll get to those in a second. So you do this in the AI functionality. So what you do here is you're going to implement the follow behavior and you're going to implement the patrol behavior. And again, this is just like for auto E in M entity manager dot get entities. So these are all your entities. If E has component C follow, then that's where you implement your follow stuff. What's this? C follow is undefined. What's that actually called? C follow player. Okay. So over here, this is where you would implement your following behavior because this entity has a follow behavior. And similarly, you do this for C patrol as well. Okay. That's where you'd implement that. So let's get rid of this. We'll go back. Next, we have some new physics. Okay. So implement the physics line intersect function, which will allow you to test whether or not two line segments AB and CD are intersections, and where they intersect as well. Then you want to implement physics entity intersect, which will allow you to test whether line segment AB intersects with any lines of the bounding box of entity E. So what the hell does that all mean? Well, over in physics, we've got some functions now. So get overlap and get previous overlap. If you got this to work in assignment 3, you can literally copy and paste your code here. Okay? So you can copy and paste your get overlap and get previous overlap from assignment 3. Next, you may want this function, for whatever reason, is inside, which takes a position and says whether or not that position is inside the bounding box of an entity. There's another function which is line intersect, and this is does line AB intersect with line CD? And if you give me a second, lectures, here's the ray casting lecture, okay? If we go down to the ray casting lecture, boom, line intersect. Vec2 ABCD, here is all that stuff, okay? That's basically that function done for you. All right, so that's that function. And then the entity intersect function takes a line segment AB and tests whether or not it intersects with the bounding box of an entity. So what the hell do I mean by that? Okay, so let me copy and paste, or I can just blow this up. So here I'm going to have this. So let me crop that, resize it to 200. All right, so this is line intersect. Does this line intersect with that line, right? This is A, this is B, this is C, this is D. That's what this function does, line intersect. Really, really easy. But what does entity intersect mean? Here's what that means. I'm going to take this entity, and I'm going to have its bounding box right here. This bounding box is actually made out of 4 lines. Okay? So what you have to do, if you have a line like this, you have to tell whether or not this entity blocks this line. Because what this line is, this could be the player, and this could be a follow behavior NPC, and you need to know whether or not the line between the center of them intersects an entity. So, based on this entity's position, which is the center, and its bounding box size, you have to do the following. So, you're given, in this function, line segment AB. Okay. So, line segment AB, this is what you're given right here, and you're given entity E. So what you have to do is you have to calculate, does line segment AB intersect with this line segment, the one at the top of the box? Does it intersect with this one over here at the right of the box? Does it intersect with this one here at the bottom of the box? And does it intersect with this one here at the top, at the left of the box? So you have to figure out this point, right? So let's just say you call these P1, P2, P3, and P4, okay? So you've figured out somehow P1, P2, P3, and P4. Now you have to check, does AB intersect with line segment P1, P2? And so what you would do is the following. Oh, I opened up a mapping program for EverQuest by accident. So you figured out Vec2, P1, P2, P3, P4. Let's say you have all of those, okay? So what you do now is you say if line intersect, because you've already written that function up here. So you say if line intersect A, B, P1, P2, then return true, right? And you do this for all 4 of that. Well, I guess you might need the physics, right? So this is what you're doing. You first have to calculate these 4. And so you have, what are the 4 functions? You have P1, P2, P2, P3, P3, P4, and P1, P4. So P2, P3, P3, P4, and P1, P4. Okay? So that's how you would do that function, is the calculation of these and then doing those 4 line intersections. All right, that is how you do vision calculations. It's tedious, but it works. Then you're going to use this, what you just did, right here, to implement the NPC following behavior, right? Because now you can tell if something is blocking vision or not, right? Then you implement invincibility frames, implement the heart pickups, and then implement the black tile teleporting. All right? And then you're done. And I know it sounds like a lot, but a lot of this was already done for you in assignment 3. So let's move through this function, just this class once more, just to see if I'm missing anything. So in the init function, you need to register your actions. You need to implement load level to load the level properly from the file. Get position converts room and tile positions into world positions. Spawn player is going to spawn your player. Spawn sword is going to spawn your sword. Update, you have to implement the pause functionality in here. Movement, Of course, you have to do the movement function, right, based on your speed and your inputs. Your do action function, that's pretty obvious what that does. Your AI is here. Oh, so invincibility and lifespan are now going to be done in the status scene, in the status system. Okay, so inside S status, that's where you're going to implement lifespan and also where you're going to implement the invincibility frames. Okay, your collisions go here, your animations go here, your camera goes here, and rendering is all done for you. Cool. All right, that's it. So all that stuff is in Scene Zelda, and then there's some stuff in physics that you have to do as well. Just these functions. Let me see. Is Vec2 done for you? Vec2 is already done for you. Cool. So that's it. Assignment 4. Looks pretty cool. Oh, let me go over the marks because the marks are a little bit different this time around. Where's the marks file? All right. Here's the marks file. I've changed it up. So what happens is it's surprisingly difficult to come up with a marking scheme that adds up to 100 sometimes. So let me just read this. For this assignment, marking will work a little differently. The marks on the right do not add up to 100%. However, instead, you will lose the given amount of marks if the feature is not implemented properly. This means that instead of starting with 0% on the assignment and gaining marks for not implementing functionality, you are starting with 100% and losing marks based on things which are not finished. Okay? So it's just kind of a semantic way of doing it, but it lets me mark much easier. Rather than starting with 0 and adding everything up, I can just check off features that are missing. So let's have a look. So for the drawing of and animations, all the entities are drawn properly. Entities are in the correct rooms. They're centered on their tile. That's worth 10%. Player animations are set properly based on the state. That's worth 10%. Sword animations are in the correct place. And this 150 millisecond lifespan is actually 10 frame. Apologies for that typo. Gameplay functionality. So all the different functionalities, those are all worth specific marks. And it turns out, and of course, any bonus features that you implement for this worth up to 10% on the assignment, okay? However, the whole assignment adds up to like 130 or something like that, but 100 is still the maximum value. It's just that now I'm able to place more emphasis on certain things, and it's easier to mark it this way than like having something worth 7.5 and something worth 6.8, right? So it's essentially the same thing. It's just different. Okay. Cool. So that's the marking. It's all there. It's pretty detailed. So if you really want to min-max your marks versus time spent, then go through that. All right. So that's assignment 4. And it seems like a lot of work, but just remember, it's not going to be that much work. Trust me, once you get started on it. It takes almost as much time to talk about it as it does to implement, honestly. But all of that stuff is required for the project, right? So working on assignment 4, your project is going to be half done for you by the time you finish assignment 4. So it really is a good opportunity to make those systems and get them out of the way and do them well, because you're going to have them on the project eventually. All right. Great. That's it for me. Remember, the next class on Tuesday is not a class. That is going to be, that's Remembrance Day, so there's no lecture there. And then we'll start again in 1 week with the next lecture. So you got lots of time, lots of free time to work on assignment 4. All right. That's it for today. Thanks a lot. I'll see you next time.